In this lecture, we're going to talk about the object class in Java. So every class that we declare directly or indirectly inherits from the object class. So earlier we declared this text box class. This class extends or inherits from the UI control, and UI control in turn extends or inherits from the object class. Now here we didn't explicitly type extends object. The Java compiler automatically adds this for us. That is the reason why every class that we declare has some additional methods. What are these? Let's take a look. First, I'm going to delete this code. Now back to the main class. Let's declare a variable, call it opt, and set it to a new instance of the object class. Look, this class is declared in the java.lang package, so it's available everywhere. Now let's look at the members of this object. So we have the getClass method, which returns a class object. And with this, we can read metadata about an object. For example, we can find all the fields and methods defined in that object. Next, we have equals, which we use for comparing objects. We have hashcode, which returns an integer based on the address of this object in memory. We're going to look at this in a second. We have toString, which returns the string representation of an object, and a few other methods like notify, notify all, and wait, which are used in concurrency. That's an advanced topic, so for now, let's not worry about it and focus on these basic methods. So I'm going to delete this code and create a new text box object. Let's call it box1 and set it to a new instance of the text box. Now let's print box1.hashcode. We get this integer, and this is calculated based on the address of this object in memory. A lot of people think this is the address of this object in memory, but that is not correct. The address of this object goes through a special function called a hash function, and the job of this function is to get a value and map it to a numeric value, which we call a hash. So this is the hash code of this object. Now, why does this matter? This hash code is used in a lot of situations. One of them is comparing objects for equality. Let me show you. So I'm going to declare a second variable. Let's call it box2 and set it to box1. Now you know that both these variables are referencing the same object in memory, so they should have the same hash code. Let's take a look. I'm going to duplicate this line and also print the hash code of box2. As you can see, we get the same values. Now, earlier I mentioned the equals method. So with this method, we can check objects for equality. Now, if we pass box2 here, this method will return true because both these variables are referencing the same object and they have the same hash code. However, if I create a new text box here, now this method will return false because these two objects are in different locations in memory and they have different hash codes. Now, there are situations where we don't want to compare objects by their hash code. We want to compare them based on their content. For example, imagine we have a point class. A two-dimensional point has x and y coordinates. Now, if we have 2 point objects and both these point objects have the exact same coordinates, technically they're equal, right? So in that case, we don't want to compare 2 point objects based on their hash code. We want to compare them based on their content. This is one of those situations where we can change the implementation of the equals method. So instead of comparing objects by their hash code, we can compare them using the values stored in their fields. We'll look at that later in this section. Now finally, let's look at the toString method. This method will return the string representation of an object, which has 2 parts. The fully qualified name of the class, which contains the package it originates from, followed by an @ sign, and finally the hash code represented as hexadecimal. If you're not familiar with hexadecimal, it's a numbering system that goes beyond our decimal numbering system. In the decimal system, we have the digits 0 to 9, but in hexadecimal, we also have the characters A to F. So this value you see here is the hash code of this object represented in hexadecimal. Now, once again, there are situations where the default implementation of the toString method is not desirable, but we can always change it. For example, if we have a point class, we can change the toString method. So instead of returning this string, it will return the x and y coordinates. So this is all about the object class. Next, we're going to look at constructors in inheritance.